hope the screen is visible. Good evening, everyone. Okay, I'm audible, right? Okay. Okay. So let's start with the session. It's week 2, and most of you might have joined last discussion class also. Anyway, we will directly move on to the presentation. And this week you had looked at matrices, introduction to metrics, independent and dependent variables, and variables, solving system of linear equation, then vector, norm, orthogonal vector, basis vector, and half space. Also you have looked at eigenvalues, vectors, symmetric matrix, null space, how to find out the eigenvalues in vectors, all those things you have seen. So in your assignments also you might be having these questions. So I'll be discussing some questions with you, and along with that the basic theory behind that, many of the questions. In the last discussion class, the basics and theory behind the questions and some of the questions were discussed, as I have discussed with the other person. So today I'll be discussing with you about the previous assignments which were given in the past 2 courses of this data science for engineers course. Okay, so let's move on to this thing. So first I have just given this one. Matrix is an organization of data into rows and columns. So today we will be looking at matrices, how to create them in RStudio also. So here I have given rows as samples. So in data science scenario, whenever you are collecting some data about some attributes or features, so the rows represents the number of samples which are taken in that particular data set, and the columns will represent the variables or values. So for example, I have just given a biomedical data set of 1000 patients. So in this particular biomedical data set, there is the serial number which gives you the number of subjects which were tested or from whom the data was collected. Then there is the weight, height, and age. So these are the different features which were collected. So the columns represent the variables or the features. For example, these are weight, height, and age, and the rows represent the samples taken for each of these different values. Alright, so this is an example of a data set collected, and this is in the form of a tabular data. Okay, so there are different forms of data and all, which you will see later in the advanced stage of data science. Okay, so another thing, important thing you might have seen is independent and dependent variables. So independent variables are the variables that store unique information, and dependent variable is the variable which is formed by the combination of already existing variables. So for example, if you have such a data set like this, in this data set which I have shown earlier, there is the weight, height, age, and BMI. So you know that BMI is has a relationship with the height and weight, right? So BMI will be like it has a relationship between the weight and height. So in that case, you can say that the column is dependent on the independent variables which are weight and height. Okay, so if I write it, then does anyone want to speak? No, okay, yeah. So if you can say that for example, you can say that this BMI, okay, just wait a moment. Okay, I have some problem with my pen. Okay, so BMI is given as, can anyone say what is its relation between weight and height? Okay, let me see the chat.
Weight by height square.
Yeah, weight by height square, that's right. Just wait a moment. Rajwan Kohli, the contents are not shared in the, it's shared in the Google Drive. Are you not able to access it?
Not able to access the Google Drive.
Okay, let me see. After this class, I will just check the access, okay?
Okay.
Yeah. Then, okay, everyone is not accessible. So, maybe there is some problem. Okay, okay, just let me just wait a moment. I'll just check that now, okay? Can you try, those who have not able to access, can you try once again?
Yes, it is working now, but thank you, it's working.
Okay. Yeah, the link is shared in the discussion forum, okay? The same link only. I think it's accessible now. Let me just check once more. Okay. Yeah. So week 2's the material I'll be sharing today. Okay. Week 1 is there right now. Okay. The link I can share now. So I think it's shared now. Check the access. Okay, yeah. Okay, we'll come back to the presentation. Okay, so BMI, so you have told like it's like weight by height square. So you can see that this particular column has a relationship between the weight and height. Okay, height in meters. Okay, so if you this BMI is a dependent variable. Example for dependent variable here is BMI. So that is about dependent and independent variable. Then okay, rank and nullity. So rank is the number of independent variables or samples. So we will be looking at more number of problems about this particular topic. So rank you can get by seeing the number of independent variables, and nullity will be the number of linear relationship. So rank nullity theorem you might have studied, like nullity plus rank will be the total number of variables. For example, if in this particular matrix A, the number of, okay, people are still joining. Yeah, so A is 121, 240, 360. The number of variables is equal to 3. Rank of A is 2 and nullity of A is 1. So why is it coming like that? Because you can see 1, 2, 3 and 2, 4, 6. This particular column, okay, this particular column is related to the other one. So there is dependency. So you can say rank of A is 2 and nullity of A is 1. The thing that you have to, how can we say variable is equal to, can you clarify that question? How can we say variable is equal to? I didn't get that question. Number of variables equal to 3. Okay, so that you have to see the matrix shape. Okay, this is like a 3 by 3 matrix. So the total number which can be included, total number of variables which can be included in that matrix will be 3. Okay, and so first when you get a matrix, we will see with this with an example actually. So right now you can look at this one. So A is given as 1, 2, 3, 2, 4, 6, 1, 0, 0. Okay, this is the matrix. So this is a square matrix 3 by 3. So each of the rows can be given by 3 variables. Okay, you can see column wise or row wise. Okay, both you have to look. So here if you see it column row wise, how it will be, can you say 1, 2, 1, 2, 4, 0, 3, 6, 0. Okay, so if you see it row wise, you can simplify this matrix as 1, 2, 1. Okay, let it be 1, 2, 1. Then the second row you can take 2 as common, it will be coming 1, 2, 0. And the third row, if you are taking 3 outside, that also will be coming as 1, 2, 0, right? Okay, is that fine? So this is how we took like row wise. Okay, so if you see row 3 and row 2, there is a relationship, right? Otherwise, if you can see the other way, this column 2, that is what is written here, column 2 equal to 2 into column 1. Both relationships are there. Anyway, if you see, if you reduce this thing, okay, if you do like R3 gives R3 minus R2, if you do, it will end up with a row of zeros. Okay, so you can say that rank is 2 in this case. Okay, if you do in that particular operation, you can say rank is 2. Otherwise, if you are looking column wise also, it will come like for example, I will write here A equal to, this is 1, 2, 1, 2, 4, 6, 3, 6, 0, sorry, 2, 4, 0. Okay, so this is the thing. And if you can just write this as 2 into 1, 2, 3, let it be there. This will be 1, 2 into 1, 2 into 2, 4, and 2 into 3, 6 will come, and 1, 0, 0. If you see like this also, there is dependence between the columns. Okay, so here also, if in this way, if you see also, it will be like rank is equal to 2. Okay, so if the number of variables for a matrix is 3 and the rank of that matrix is 2, then there will be, according to the rank nullity theorem, there will be the number of nullity will be 1. Okay. So variable minus rank is equal to nullity. That one of the person Jason has given. So that is how you will find the nullity. So how to calculate nullity equal to 1? Okay. So number of that is nullity is equal to number of variables minus rank of A. Okay. First you have to find the rank of the matrix, or find the number of columns which are having relationship, and then you have to go with finding the nullity. Okay. So that is how you find the nullity, and in that nullity case or the null space, there will be like this particular determinant into this one will be equal to 0. That will be coming. Okay. So this is the first question for this particular assignment. So I think I'll give you a moment to find the answer. Okay. So you are asked to find the rank of the matrix. So the first thing is that either you can find the determinant of this matrix and see if it is equal to or not equal to 0. Okay. Or another way is like you find if there is any linearly dependent rows. Okay. So first you can do these things. So Vivek has answered 2 and Jason has answered 3. Okay. Why Vivek, can you tell why you have given us 2? Vivek, can you tell what is the determinant that you are getting? Okay, many people are giving 3. Okay, no problem. Yeah. So if you calculate the determinant, can anyone say the answer? What is the determinant? I think it is somewhere around like, okay. So if the determinant, if you are calculating the determinant is not equal to 0. Yeah. Determinant is not equal to 0 in this case. It's somewhere around 3 or something. Okay. Yeah. Okay. So it's equal to 3. I think it will see 13. Okay. I'm not sure. Okay. Maybe. Okay. Let me calculate. So 1 into 27 minus 30 minus 2 into 18 minus, okay, it's not coming, 24 plus 3 into 10 minus 10 minus 12. Okay, 10 minus 12. Some are saying 15. Is it right? Can anyone say? I am getting it as 3. Yeah, some has got as 3. Okay, anyway, yeah. Anyway, the determinant is not as equal to 0. That is one thing by which you can find. Or look at these rows and columns. Okay. See if these rows are related. Okay. 1, 2, 3. Any relation with 2, 3, 6? No. And any relation with the row wise relation with these 3 rows, which is 4, 5, 9. No way you can relate it with an equation. Okay. It cannot be a linear combination of any of the rows. So anyway, and look column wise also. 1, 2, 4, 2, 3, 5, 3, 6, 9. Okay. There is no way that you can relate these 3 columns also. I mean, you can't say. Okay, so all are independent. So you can say that this particular matrix has rank equal to 3. Okay. So after we solve all these problems, we'll go to the RStudio also and find it out. Okay. So, or let me see. We'll just check it now itself. Yeah, so okay, so I will just tell this one. I mean, the matrix was given like 1 2 3. So how do you form the matrix? Your matrix was given like 1 comma 2 comma 3. Okay, 2 comma 3, and then it was 2 comma 3 comma 6, 2 comma 3 comma 6 comma, and 4 5 9, 4 5 9. Yeah, and the number of columns you can give as 3, and it is like by row 1 2 3 2 3 6 4 5 9. Okay, so this is the matrix. Okay, so if you do that, A is given here. Okay, so A is, I'll just increase the size. I hope it's visible right now. Okay, so 1 2 3 2 3 6 and 4 5 9. This is the matrix A, and then we will find the determinant once. So determinant is coming as 3. Okay, so determinant is 3, so it's not equal to 0. You can say that the rank is this one. Okay, so directly if you say like rank, sorry, this rank I have to see. Okay, so rank of A, sorry, rank of A, if you see, then it is coming as 3. So this is another way. So this is your matrix. If you want to find the determinant, det of A, and if you want to find the rank of A. Okay, so there is another thing also that you can find. In between you might be confused with this another one. Okay, I think it was explained in the doubt section, but anyway I will just tell you. I mean, if you look at this particular thing, rank. Okay, so this is, you can see the returns a sample ranks of values in a vector. Okay, so this is different from the rank of a matrix. Okay, so this is our thing. So we'll come back to the next question. I think everyone is fine with the question. If any doubts, you can ask in the chat window. I'm just waiting. So okay, so I think it's fine. So we'll move on to the next one. Let n be a 2 by 2 matrix with trace equal to 4 and determinant equal to 3. Find the eigenvalues of n. So there is a relation, right? Eigenvalues. So it's a 2 by 2 matrix, so you can assume that let there be 2 eigenvalues, lambda 1 and lambda 2. Okay, it's given like the trace is equal to 4 and determinant of that matrix is, the determinant of that matrix A, okay, that equal to 3. Okay, so can you find the eigenvalues? So just what you have to give is, you know that the sum of the eigenvalues will be 4 and the product of eigenvalues will be equal to the determinant. Okay, so yeah, some has written 1 3, Pranav has given 1 3. What is trace? Trace is like the sum of the diagonals, right? The diagonal values of a matrix is there now. Okay, so sum of the elements of the, if I want to show you, so this is like this is the principal diagonal. Can you see? Okay, so you can see 1 3 and 9 forms the principal diagonal. The sum of these three values 1 plus 3 plus 9 will form the trace of that matrix. Okay, Jason, is it fine? Okay, so in the second question the matrix is not given, so it's just told that the sum of the principal diagonal elements is equal to 4. So the sum of the principal diagonal elements will be equal to the sum of the eigenvalues, and product of the eigenvalues will be equal to its determinant. Okay, so yeah, some have found out and given the answer as 1, 3. Okay, so has everyone found it out? This is easy only. Okay, just find out, I mean from this you can find out lambda 2 equal to lambda minus 4 minus lambda 1, then lambda 1 into 4 minus lambda 1 you can put equal to the determinant which is given as 3. Solve this equation which will be coming as 4 minus lambda 1 here. So it will be coming like lambda square minus 4 lambda 1 plus 3 equal to 0. Sum is giving 2 as the answer. Why? This will be like lambda 1 minus 3 and lambda 1 minus 1 equal to 0. Here also equal to 0 is there. Okay, so lambda 1 will be 3 comma 1. Okay, Navya, I think why have you got 2 comma 2? Okay, I hope it's clear now. Navya, have you seen the calculation? Okay, let's move on to the next question. Okay, yeah. So, which of the following can be the eigenvector of the matrix A equal to 1, 2, 4, 3? Yeah. So, this you can find out and tell me what can be the eigenvector. Minus 3, I didn't understand, Jason, your query. Just I'm going back to the previous one. 1, 3 comes, it is minus 3, meaning like are you giving like if you put, okay, if lambda 1 I am taking the value as 1, then lambda 2 will be 4 minus lambda 1, that means 4 minus 1, that equal to 3. Okay, when you putting the value of lambda 1 value as 3, then lambda 2 will be 4 minus lambda 1, which is equal to 4 minus 3, which is equal to 1. Is that fine? I didn't understand why you're giving as minus 3 there. In that equation, have I given minus 3? Sorry, wait. Lambda 4 lambda 1 minus lambda 1. Okay, I will write it here. 4 lambda 1 minus lambda 1 square equal to 3. That means 4 lambda 1 minus lambda 1 square minus 3 equal to 0. If you are taking the common as minus 1, then it will come as lambda 1 square minus 4 lambda 1 plus 3 equal to 0. Is this the query? Okay, so now it's fine, right? Actually I had skipped the steps in between. It is coming like 4 lambda 1 minus lambda 1 square equal to 3. It can be given as 4 lambda 1 minus lambda 1 square minus 3 equal to 0. That means lambda 1 square, if you take the minus 1 outside, lambda 1 square minus 4 lambda 1 plus 3 equal to 0. Okay, yeah. So I think, I hope it's fine. Okay, yeah. So which among the following can be the eigenvector for the matrix A equal to 1, 4, 2, 3? Okay, so how do you find the eigenvector? First, this is the matrix A is equal to 1, 2, 4, 3. So first you have to find determinant of A minus lambda I and substitute equal to 0 to find the eigenvalues, right? So A minus lambda I means 1, 2, 4, 3 minus lambda into 1, 0, 0, 1 equal to 0, right? So what are the eigenvalues that you are getting, if anyone has done it? So this will be like, I'll just solve in the meantime. So it will be like 1 minus lambda, 2, 4 and 3 minus lambda, its determinant equal to 0. That means 1 minus lambda into 3 minus lambda minus 8 equal to 0. Yes, okay, people has given us minus 1, 5. Okay, that is fine, that is the true answer. Anyway, I will come to that. Yeah, so it will be coming like 3 minus 3 lambda okay, so sorry, 3 minus lambda minus 3 lambda plus lambda square minus 8 equal to 0. So you have to solve 4 lambda square minus 4 lambda minus 5 equal to 0. It will come like lambda minus 5 and lambda plus 1 equal to 0. Lambda values are 5 and minus 1. Answer of this question is option 1 and 4. Okay, 1 is 1, 2 and 4 minus 1, 1. Okay, we'll see. So okay, first what is the step for others? The first step is to put value of lambda equal assume the value of lambda equal to 5, and in the equation ax equal to lambda x you have to substitute. So a into x, 1, 2, 4, 3 into x, since it is 2 by 2 matrix, 2 variables x1, x2 equal to lambda we are right now doing as 5 into x1, x2, right? Okay, if you solve for this one, it will be coming around x1 plus 2x2 equal to 5x1. So from this, and 4x1 plus 3x2 equal to 5x2, from this you will be getting like both cases you will be getting as x2 equal to 2x1. By that method, if you look, you can just say like x1, x2 equal to 1 and 2. That is one of the case. Okay, then another one, lambda equal to minus 1 if you put, then it will be like 1, 2, 4, 3 and the next one x1, x2, and here it will be minus 1 into x1, x2. Okay, so x1 plus 2x2 equal to minus x1. Another thing will be giving us 4x1 plus 3x2 equal to minus x2. So here you will be getting it as 2x1 plus 2x1 plus 2x2 equal to 0. That means x1 is equal to minus x2. So you can find out from the option. So one option is 1, second option, so you have decided that 1, 2 is one of the option. Then 1, 1 won't be coming because x1 equal to minus of x2. So if x2 is 1, x1 cannot be 1, that is not there. Then this 2 comma 1, so if x1 equal to, from here if we find out that if x1 is equal to 2, then x2 should be 2 anyway, 2 into 2 anyway, so 4 should be coming, so this is false. So these two options are not there. And in the other option it's like x1 minus 1 x2 1. So here you can put if x2 equal to 1, then x1 will be minus 1. So in that way you can tell that this option is also correct. So Vivek is right, 1 4, yeah, AD. So the answer is the eigenvectors can be 1 2 or minus 1 1. Okay.
Hello, ma'am.
Yes, tell me.
Ma'am, like here A is equal to lambda into x is there, no?
Which portion can you tell me?
No. Means you did here.
Can you tell me where? Which portion?
Third question. Now you are in final value for the matrix to 1 2 4 3.
Your voice is not clear to me. Can you type in the chat window?
Yes, ma'am.
Okay. So I hope everyone else is clear. Then option 1 and 4. Okay. Yeah. How is here x1 and x2 is 1 and 2 for question 3. Okay, yeah. So here you can check in the case lambda, one of the eigenvalues is 5 vanilla. Okay, so you have to substitute in this equation ax is equal to lambda x. Okay, so it will be coming like x1 plus 2x2 equal to 5x1. And the other equation is 4x1 plus 3x2 equal to 5x2. Okay, so here in the first equation if you try, it will be coming like 2x2 equal to 4x1 implies what? x2 equal to 2x1. Okay, that is one thing. If you solve this equation, it will be coming like 4x1 equal to okay, here one problem is coming, right? Sorry, 4x1 equal to 2x2, so x2 equal to 2x1. So vanilla, is it fine? So I mean, so if we are assuming, so look at the options. If x1 equal to 1, then x2 should be 2 into x1 means x2 should be 2. All right. Okay, yeah. So these are the answer. A and 1 and 4 are the answers. Okay. We'll move on to the next question. So A equal to 1 minus 1 to 2. Suppose the eigenvalues corresponding to A transpose are A, B, C. Then find the value of AB plus BC plus AC. Can you do that? So I have a matrix here. Okay. It's A equal to minus 1 to 2. what will be A transpose? A transpose will be minus 1, 2, 2 like this, and A into A transpose will be, so you can see from here, you can see this is a 3 by 1 matrix and this is a 1 by 3 matrix. So if you multiply both of these, it will be coming like a 3 by 3 matrix. Okay, Salman, what is your query? If you have a question, you can unmute yourself and tell. Rest of you can solve the problem, okay? And tell me the answer. Okay. So anyway, I am looking in the chat box if anyone has a, okay, 9. Okay, what are you giving the answer for? The value of AB plus BC plus AC you are giving? Okay, Jason. So I mean, I'll just write the matrix. Okay, so it will be like minus 1, 2, 2, and anyway, this is, you can find it very easily in RStudio, but still anyway, we will compute it once and then we'll move on to the RStudio. So if you do it, minus 1 into minus 1 here will be 1. Then it will be coming as minus 2, then here minus 2, 2 into 2, 4, 2 into 2, 4, then minus 2, 4, 4. This is the matrix. Can you see any, I mean, can you tell anything about this matrix? What kind of matrix is there? Is the rows linearly dependent or independent?
Dependent.
Yeah, it's dependent. Okay. So, yeah. What is the characteristics of dependent, if you have dependent columns or rows? What will be the determinant of A transpose if there is dependency? Will be equal to 0. Yeah, that's right. Determinant of A and transpose will be equal to 0. Okay. So in that case, I mean, here another thing that you can look here is that all these rows, the rank of the, can you tell me the rank of this matrix? Rank of A transpose will be how much? Okay, 1. People are putting yes, 1. Yeah, because you can write all these rows as a combination of this particular first row, right? You can write, how can you write this? Minus 2 like this. You can write the matrix first row, and the second rows you can write taking out minus 2 common. You can write, I mean, like you can write it here, 1 minus 2 minus 2, and here also taking out the common, here also you can write 1 minus 2 minus 2. Okay, so that is can be written like that. You can get the rank as 1. So if the rank is 1, then the nullity will be 2 according to the rank nullity theorem. Here rank is equal to 1, nullity equal to 2. If nullity equal to 0, there is a chance that there are 2 eigen values which are 0. Okay, I think you have seen in this in your lecture, 2 eigen values are 0 here. Okay, so it means that A, B, C are given as the value. So one of the eigen values, okay, we haven't found out, that will be there. And then B equal to 0 and C equal to 0. So I think Jason has answered it as 9. So one of the values is anyway 9, that we'll see in RStudio later, and the other 2 are 0. So anyway, the answer of this will be 0. Okay, so the value of AB plus BC plus AC equal to 0, and the other eigenvalue, okay, I have to see it. So I think we will move on to the RStudio. Okay, so I have written this earlier itself. Okay, so this is the matrix A equal to matrix C of minus 1, 2, 2, and I have given as number of columns 1 and by row equal to false. Okay, so I have given it like this. Now you can see A matrix is like minus 1, 2, 2. This was your question. Now I have given AT equal to transpose of A. Okay, so this is the transpose of A. So that we have given as AT. So AT you can see like -122 here. Then I have given B equal to A into AT, A transpose. So B is this matrix. Sorry, A. Wait, I have done something wrong. Have I done something wrong? Sorry. If it was in the other way, you have got as 9. So here it is giving like 9 directly, and eigenvalue is giving as 9. Okay, so this answer is for if you have like this. Okay, so if you had reversed the order, -1 2 2 1 minus 1 2 2 2 like this, like it have calculated. If this was like this, so then the answer would have been 9. Okay, so it's calculated like that. So anyway, both are symmetric also. Okay, so like this also you can find, the other way also you can find. Any questions? Okay, just let's move on to the next one. Okay, this you can answer, everyone you can answer. Which among the following is true for an n by n matrix? There is a problem with this one. Okay, yeah. If lambda is eigenvalue of A, then 1 by lambda is an eigenvalue of A inverse. Determinant of A inverse is determinant of A whole inverse. And let B be an n by n matrix, then determinant of AB is equal to determinant of A into determinant of B, or all of the above. What is true among these? Tell me the answer. Everyone? Okay, D. Is everyone okay with that? All of the above, yeah. Okay, so I think it's clear, theoretical only, yeah. Then check if the following set of vectors are linearly dependent. Can you tell me how you can solve this one? So it's given like -2 minus 1 3, another vector is 1 1 minus 2, and 3 minus 3 8. Can you please explain last one, how or true? Okay, so it's like the property. Okay, so A, its eigenvalue, if it is given as lambda, then A inverse, what is A inverse actually? It is like 1 by determinant A into adjoint of A. Okay, so this is actually, you can check the lectures. Okay, it's actually a property. So this is lambda is this thing. Okay, lambda is there. Here it is coming like 1 by determinant A into adjoint. Okay, so according to the property, you can tell that the eigenvalue of A inverse will be 1 by lambda. Okay, in the second option, it's given like, it's taken like determinant of A inverse. Okay, so determinant of A inverse, you can tell like A inverse, if you write like 1 by A into determinant A, that will be equal to determinant of A inverse. This I think you can go to the lecture section and it's explained there. Okay, Monica? And this property, this particular property, This is also a property. Okay, it's explained there nicely. Okay. 2 minus, so okay, so we'll move on to the next one. 2 minus 1 3, 1 1 minus 2, 3 minus 3 8. Okay, can you tell me if these vectors are linearly independent? Jason has told all are independent. Okay, okay. So what you can do is find out the determinant. Okay, so like this you can do, or for simplicity we'll move on to RStudio, and I want the question actually. Okay, wait a moment. Okay, the matrix is 2 1 3 minus 1 1 minus 3 and 3 minus 2 8, right? Just wait a moment. Minus 2. Okay, so what you can do is, if you want to check if a set of vectors are linearly independent, just find their determinant. Okay, so just find a determinant which is I'm just forming like a matrix A equal to this one, and I'm going to find out the determinant of A. Okay, so the determinant of A, so this is the matrix, I think 2 1 3 minus 1 minus 1 1 minus 3 and 3 minus 2 8. Okay, determinant of A. Okay, so determinant, you can see it's coming like a very small value, right? Actually the meaning is like it is 0. Okay, so determinant of A, when we gave in the RStudio, it came as 0. Just immediately you can use 2 into 8 minus 6 minus 1 into minus 8 plus 9 plus 3 into 2 minus 3, right? Okay, 2 minus 3. So it is coming like minus 4 minus 1 plus, okay, wait, this is coming like plus 4, this is coming like minus 1, and this is coming like minus 3. So the answer is RStudio, you enter 3 minus 2 8. Sorry, let me check. 2 1 3 minus 1 1 minus 3 3 minus 2 8, it's fine. Jason, 3 minus 2 8 is fine. Now I have given by row equal to true. Okay, so A is coming like, okay, wait, A is coming like 2 1 3 minus 1 1 minus 3 and 3 minus 2 8. Yes, okay, yeah. So anyway, it's fine. So determinant, I'll just once more give. So it's coming like minus 1.165 into 10 raised to minus 15. That is close, very close to 0. So, or when we calculated it like this, also we are getting as 0. So if we are getting a determinant which is formed with these 3 vectors as 0, then you can say that these 3 vectors are linearly dependent. Okay, dependent. If they were linearly independent, then determinant would have been not equal to 0. Okay, how to check linear dependency? If the resultant matrix is not square, you can check, right? Anyway, you can check the determinant if it's not a square matrix also, right? Prajna, is it not possible?
Ma'am?
Yes.
Am I audible? Here, for the 3 vectors, there are 3 components. So we can make one matrix, and that matrix is square. Number of rows equal to number of columns.
Yeah.
Right?
Yeah.
But for the vector, suppose ki if we make a matrix from the vector, and if it is 2 cross 3, then how to check the linearly dependency or independency? In that case, we
2
cannot take
cross 3. Okay, okay. Okay, that time we can just check in here. Okay. 2 cross 3 you have told. Okay, so I think this will be coming like so A is right now this 2 cross 3. Okay, so let me see what will be coming. So in that way what you have to see is you have to do the row reduction. Wait, let me see. Okay, so here you check, is there any dependency between the rows or columns? Pratnya,
Yes, ma'am.
is row 1 related to row 3, row 2? Can you form a dependency between?
No.
Yeah, it's not related. Okay,
Mhm.
then if any of these three columns are related,
No, ma'am.
so now you can say that there is no dependency, right?
Yes.
Okay, so in that case, in that particular case, when you see the determinant, it's not possible. So you can directly look at the equation. Okay, sorry, directly look at the matrix and see if there is any relation. Okay, if in case it is a very big matrix, then you have to see the row reductions. Okay, like or column that I think you have studied earlier. Okay,
Okay,
yeah.
ma'am. Thank you.
Yeah, okay. So we'll move on to the next one. So here in this case anyway we can find the matrix here. Okay, so that's why directly we have given like this. I have given like this, or you can just look at these two rows how they are related. Okay, these two rows are anyway related, that's why we were getting the determinant as 0. Okay, so let's move on to the next one. Which of the following set of vectors are orthogonal? So can you just tell me the property of orthogonal vectors? What have you studied? So if we are looking at
Dot product 0.
yeah, dot product will be 0. Okay, so look at we'll look at one example. 1 minus 1 minus 2 2 0 1. Okay, these are the vectors. So what you have to do, one of them you have to take as a transpose. So anyway, so like what can you do? 1 minus 1 minus 2, this you have taken as a transpose, and 2 0 1. Okay, product is 0. Jason, which one you are? Okay, yeah, dot product is 0. Yeah, so what is the answer for this one? 2 plus 0 minus 2 equal to 0. Okay, so you can tell like the first one is orthogonal, right? Yeah, so people have already put answers. So Pradnya has put 1 4, so okay, I'll just check that itself. 5 2 3 and minus 2 4 6. Okay, so this is coming like minus 10 minus 8 plus 18, that will be equal to 0. So yeah, so everyone is answering 1 4. So I think that's very clear. Okay, if anyone is having doubt, I'll explain it. Okay, okay, I think it's clear for everyone. So I'll move on to the next one. Okay, suppose the eigenvalues of the matrix A are minus 4 minus 3 minus 4 minus 4 minus 3, then the determinant of matrix A inverse transpose. Okay, so we have learned one, I mean there is a formula, right? the determinant of, if we have a matrix A, then if determinant of A is lambda, then determinant of A inverse is 1 by lambda. The one that formula is there. Also determinant of A is lambda, determinant of A transpose also is equal to lambda. Okay, so in this case it's given like eigenvalues are given as -3, -4, -4, -3. So product of eigenvalues is equal to determinant of A. So here we are asked to find out determinant of A inverse transpose. So determinant of A transpose is lambda only, and determinant of A inverse is 1 by lambda. So if determinant of A is lambda, so that is equal to -3 into -4 in -4 into -4 into -3, then it will be equal to how much? 16 into 9 it will be coming, right? Yeah, 144. So determinant of A inverse will be 1 by 144, and determinant of A inverse transpose also will be 1 by 144, which is given as the fourth answer. Okay, yeah. Now next one. So there is an extra question. So till now what I have explained was the questions given in the previous assignment. Okay, previous assignment, that is Jan 2023. Now these are some extra questions. Okay, so trace of 3 by 3 matrix is given as 9. So trace, you might remember, right? It is the sum of the principal diagonal elements. Then A as an eigenvalue 9 of multiplicity 2. That means lambda 1, lambda 2 equal to 9, 9, and find the determinant of A. So we know that trace of a matrix is sum of eigenvalues. We'll just go through this. Sorry. Trace of a matrix, sum of its eigenvalues. Given eigenvalues are 9, 9. So it's a 3 by 3 matrix. So anyway, total there will be 3 eigenvalues. So I have given like lambda 1 plus lambda 2 plus lambda 3. That is the sum of the eigenvalues, which is equal to the trace. That is given as 9. So since you have got both the others as 9, it will be like 9 minus 18. Lambda 3 will be coming as -9. Then determinant of A will be product of the eigenvalues. So you have got 2 of the eigenvalues as 9 and 1 as -9. So it will be 9 into 9 into -9, which is -729. Okay, this is one question. If any doubt, you can ask, or we'll move on to the next one. Then the next one is following sets is or are orthogonal. So this one you have done anyway. Okay, I'll just share this material. So here it's given as V1. So it's like you have to find the dot product of V1 and V2. If dot product equal to 0 implies orthogonal vectors. So you have to find the dot product of V1 transpose into V2. Okay, so that's how it's done. So this is similar to the question which was discussed. Okay, you can solve this in RStudio also. We'll be coming to that. Okay, so this is the question. You can find the answer. How to check option 4? Okay, we will see. Okay, so there you can give like V1 is given as 1, 2, minus 2, 4. Then the V2 is given as minus 1, 4. So any one you can try. Okay, so I will take V1 into V2 transpose. That is equal to 1 or V2 I'll take V1 transpose into V2, that will be better. So 1 minus 2 4 you can do, and the other one you have to do like minus 2 4, this dot part is not there, okay, so it will be 0 anyway. So minus 1 minus 8 plus 4 into 0 will be coming, okay. So it's minus 9, it's not orthogonal, okay. If you solve it in RStudio, it will be coming like that, okay. Otherwise you can tell that anyway, since the vectors are not like 3 by 1 or 1 by 3, I mean this one right now is 3 by 1, so this also, if you want to say if two vectors are orthogonal, the other one also should be 3 by 1, okay. So in that case anyway it's not coming, okay. Directly you can say that it will be not orthogonal, okay. If you want to show it, solve it, anyway you have to put it like there is no element here, okay, yeah. Now the next one, so that is the same case with the, okay, that is fine, everything else is fine, I think, yeah, you can find the answer. Now next one is this one, find the value of, okay, so this one you can calculate directly either in the calculator or this one, okay. Anyway it's a singular matrix, okay, it's coming like this, anyway the result will be coming like this, and so I mean you can see the dependency here, so the determinant anyway would be 0, okay. So that is the thing, anyway like it will be I mean the calculation is difficult, okay. You can just use some theorems also to find it easily, so anyway but the answer would be 0 because it is singular, okay. There is dependency, and this one, inverse of the matrix, I think we will solve this one, I mean the procedure is similar only. We will just check this particular question in RStudio, okay. So first just check if there is any dependency existing. Is there any dependency? Yes ma'am, yeah, dependency is there. So anyway if dependency is there, what will be the determinant?
0.
Yeah, the determinant will be 0, so in that case inverse does not exist, okay. So does not exist since the columns are linearly dependent, okay, that is the answer. Now which of the following is true about orthonormal vectors? Can you tell me the answer? What are orthonormal vectors?
It is orthogonal and its norm is 1.
Okay, yeah, each vector is orthogonal with unit magnitude, okay, yeah, last option, that is true. Then which of the following sets of column vectors form a basis for R4? So how have you so okay, just option A we will do 13 10 13 5 12 10 16 3 13 10 10 0, okay. Will it form, okay, some people, okay, Monica has given last option for this question, or anything else? Okay, I think it was for the previous question, okay. Anyway, will it form the basis for R4? Okay, fine. So it won't form because what is the This is a 3 by 4 matrix. Okay, so the first case is not coming. Okay, secondly, we will see the option C. What is the problem with option C, or is there any problem? Will it form? I'll just write this one. 11, 154, 22, 66 and 456, 8, 20, sorry, 24, 66. Okay, I'm looking at the answers. Column, okay, yeah, that is fine. Yeah, you're right, Jason. So in this thing, column 2, you see 1 into 14, 14, 6 into 14, you'll be getting like 84, 11 into 14, you'll be given 154, and 14 fours are 56. So column 2 equal to 14 into column 1. So what is there? There is a linear dependency. Okay, is there anything else? This is 1 into 2, 6 into 2, 12, 11 into 2, 22, 4 2s are 8. Column 3 equal to 2 into column 1. And what about column 4? Column 4 will be okay, 6 into 1, 6, 6, 6 are 36, 11 into 6, 66, and 4 into 6, 24, so it will be like, sorry, 6 into C1. Okay, so only one column is there which is not, I mean, it is linearly dependent, so its rank is coming as 1. Okay, so in that case, column 4 equal to column 3 into 5. Okay, that is column 3 into 5. Okay, yeah, that is not okay. Yeah, so these relations are there. So anyway, it won't form the basis vector for R4. Okay, that is also not true. Then look at option B. Option B is like, okay, 15, 11, 2, 1, 6, 1, 10, 7, 11, 2, 14, 11, and 14, 12, 14, 2. How is this one? Is this fine? Seems like yes. Okay, all are independent, right? So there is no problem with option B. So your answer will be option B. Okay, they are independent. Okay, now next one, let lambda 1 equal to 1, lambda 2 equal to 2. Okay, I have kind of written the answer. Okay, anyway, be the eigenvalues, and V1 is given as 2 minus 2 transpose, V2 is 3 1 transpose. Be the eigenvectors also given. Okay, so let B be a projection matrix given as B equal to V1 V2. Compute B inverse AB. Okay, so I have written already here. So B is given here as, sorry, so okay, B is given here as V1 V2. All right. Okay, so we have a relation. I mean, you might have learned this relation like A is equal to P inverse D P inverse. So here B is given as, I mean, B you can take as P. Okay, so it is like, so here B is 2 minus 2 and V2 is 3 1. That is equal to what you have seen in your equations, maybe like P. Okay, so I have written as that it as P also, P equal to 2 minus 2 and 3 1. There is also another relation which is formed with the eigenvectors. So D is equal to, you have given, sorry, eigenvalues, so you are given the eigenvalues as 1 2, and the rest you can put as 0. So this is the D vector, D matrix. So now you can see this relation. Okay, this relation is already there, A equal to P D P inverse. Okay, so P is there as 2, 3 minus 2, 1. So what you can do is just multiply it with P inverse. So you can put it as P inverse P T P inverse. So P inverse P is identity matrix. Okay, now again P inverse A, I am just multiplying it with P. So here also it will be, anyway this one is I, okay, into D into P inverse into P inverse into P. So here also this part will also be coming like identity matrix. So D equal to P inverse A P. In our case P is equal to B, so D you can give as B inverse AB or P inverse AP, and D we know what it is. It is 1 0 0 2. Okay, so your answer is 1002, option C. Okay, so this is dependent on that equation which shows that your particular A matrix can be written in this particular form. Okay, so I think this answer is clear. Any question? Okay, we'll move on to the next one. How many solutions does the system of linear equations 15x plus 20y equal to 25, 21x plus 28y is equal to 35 have? Okay, so what can I do? So you can write 15, 20, I'm writing it together, 25 as a matrix. This one also I'm writing as 21, 28, 35. Can you form any relations in this particular thing? If you take 5 common out of the first one, what will be coming? Is anything? 3, 4, 5 will be coming. And for the next one, it will be coming like 7. If it's taken out common, it will be 3, 4, 5 again. Okay, so the coefficients you can see they are linearly dependent. Okay, the coefficients are linearly dependent. So hence this is given system of equation can have infinite number of solutions. Yeah, that's fine. I hope this is clear. Okay. Okay, yeah. Then the next one, given the matrix, the eigenvectors are, I have directly written it here. So you can write A minus lambda equal to 0. This one if you solve, lambda square plus 17 lambda minus 578 equal to 0. Lambda 1, if you solve it, you will get the value as 17 and minus 34. Okay. Now assume Vi to be initially a vector x, y transpose. If you substitute the eigenvalues in this particular equation and solve for x and y, then you will get the value. Okay. This similar question I have discussed earlier. So here you can find the answers as minus 34 as minus 4, 1 and for 17, 1, 4. Okay. So this is the question. Okay, so just I think we'll move on to our studio also once and see. I'll put E equal to matrix of C of, okay, the values are minus 31, 12, comma 12, comma 12, comma 14, and I will give the number of rows as number of columns as 2, and by row I'll give as equal to true. Okay, so matrix E is coming like minus 31, 12, 12, 14. Okay, yes. So what you want to do here, you want to find the eigenvalues as well as the eigenvector. So you can do is like I'll just put EV equal to eigen of, okay, eigen of, like that I'll put of E, and then I'll run. Then what I'll do is I'll just see what is the eigenvalue. Okay, so for this value, if I run this one, then will be coming 17 minus 34. Okay, where it is 17 minus 34 is coming. Then okay, and so for the vectors sometimes the values won't be coming correctly as how you will solve. So it will come these type of values. Okay, but if you solve clearly, I mean by hand, you'll be getting these values. Okay, since it is like you'll be doing it with respect to the values, and you'll be solving the equations. But directly if you give in RStudio, sometimes you'll get values vectors like this also. Okay, but I hope the other way is also fine with you. If anyone has a doubt, I'll solve this here. Okay, I hope it's fine. I'll move on to the next one. Consider the matrix A. The columns of matrix A form the basis of null space of another square matrix B. Find the rank of matrix B. So the A matrix is given like this. Okay, so it is a 5 by 3 matrix, right? So the rank of the given matrix, anyway, since it's not a square matrix anyway, it won't go higher than 3. Okay, number of columns is 3 only. Since the columns of matrix A form the basis for the null space of B, you can say according to the theory, you can tell that the nullity of B is 3. Okay, because it's given the columns of matrix A forms the basis for null space of another square matrix B, and B here is a square matrix. A is not a square matrix. Okay, so you can say the nullity of B is 3. Okay, so you can say the null space of B should solve the equation. This is by equal to 0. That should be solved in the null space. Okay, so since the basis of null space is of size 5 cross 3 and B is a square matrix, so anyway B should be having a size 5 cross 5, right? And according to the rank nullity theorem, we have found that number of columns, anyway B is a square matrix, so it will be having 5 columns, and nullity we saw as 3, so rank will be 5 minus 3 equal to 2. Okay, so this is another question. So this is the last question. We will move on to RStudio for some examples. So first I'll move on to some solving some things with R, like finding the number of rows, number of columns, etc. Okay, if any other doubt is there, just you can put a message in the chat box. Otherwise I'll continue with this one. Okay, I'll be looking at the chat box in between. So just I have given adding 2 matrices. So matrix 1, all these things you know, right? And row number of rows I have given as 2, number of columns as 3. So if you run these 2 lines, you will be creating B matrix and C matrix. So B matrix is this one, 1 3 5 2 4 6, and C matrix is 7 9 11 and 8 10 12. Okay, so then what can you do? If you want to get the number of rows, you can give like B. Okay, so number of rows is equal to 2 and number of columns equal to 3. Okay, can you do an overview? Okay, eigen concept, what do you want there? About what eigenvalue? What portion do you want? Eigenvector. Okay, so yeah, it's like in your theory, I think it was in the, just wait for a moment, I'll come back to that. Okay, just I'll come to your, wait, okay, from here itself we can do, or okay, just wait a moment. I think this is your thing. Okay, in that I will just show you. I think you have seen this this thing, right? Okay, anyway, the relationship between eigenvector, null space, everything is given here. Okay, just wait a moment. This is one of the theory that I was saying. Okay, anyway, we'll come back to the next one. So where was the eigenvector? Just wait for a moment, I'll take that question. Okay, so is this fine, Jason? The thing is like, you have the eigenvalues. With that eigenvalues, you can find some vectors which will define your matrix. Okay, so which will define this particular equation. Just wait a moment. Here I'll do. Okay, so here you are given the matrix A 1 2 4 3, and you have to find out the eigenvector for this thing. Okay, so the eigenvector will solve this equation. Okay, Ax equal to lambda x, where x will be related to the dimension of your matrix. Okay, so if your matrix is like an n by n matrix, then there will be like n number of variables. Okay, so I mean depending on the rank and everything. So here it was like A is a 2 by 2 matrix, so you will be getting like x vector will be x1 and x2. Okay, so then you can look at this A matrix into x1 x2. If you give, it can be written as its eigenvalue into some vector which is given by x1 x2. This equation is solved. Okay, so how it is relevant to geometrically is given in the third lecture. Okay, just look in that. Okay, so how you'll solve this one is like, first you have to find the lambda value. Okay, so lambda value, I've just solved it here. So how you'll find it out? Determinant of a minus lambda, just wait for a moment. Okay, so a minus lambda I, determinant equal to 0. So this is like, you can tell like 1 2 4 3 minus lambda into I is identity matrix 1 0 0 1. So equal to 0 you have to put, and you have to solve for that equation. You will get the eigenvalues as 5 and minus 1. And then when you substitute it, like for example, first value you got as lambda equal to 5, then you can give it like 1 2 4 3 and x1 x2, you can give like 5 into x1 x2. So this you can solve like 1x1 plus 2x2 equal to 5x1, and another thing is 4 into x1 plus 3x2 equal to 5x2. So both these equations you can solve. So in the first case 2x2 equal to 4x1 will come. Finally you will be getting like x2 equal to 2x1, and in here you will be getting like 4x1 equal to 2x2, that is 2x1 equal to x2. The same equations will be coming, so x1 x2 equal to 1 2. Okay, so this is one of the equation. So here what you can see is like, this is one of the vectors, right? Okay, so in another case, if you are just telling like, so in this one there are other solutions also. So for example, if x1 you are giving as 2, then x2 will be coming like 4. Okay, that is also a possibility. Okay, x1 x2 you can give like this also. Okay, and when you solved for the other eigenvalue lambda equal to minus 1, then you got the equation like this. Okay, like this much you got 1 plus 2x2 equal to minus 1, 4x1 plus 3x2 equal to minus x2. You solved it and got x1 equal to minus x2. So if you are depending on that particular value, then you will be getting like x1 x2 equal to 1 minus 1. This is one of the case. If your x1 value was for example, if so in this case x2 value was minus 1, that's why x1 came. So if x2 value was 1, then x1 will be minus 1. So in that case your vector would have been minus 1 1. Okay, so this is particular. If x1 is 1, x2 is 4. Okay, so there are many different cases for this one also, so your vectors can change. Okay, so that is one thing. So depending on your eigenvalue, here there are many solutions. So then wait, 2 4 3 6 4 8 all are eigen vectors. You can call it like that. And again, if you go to R Studio for 1 2 4 3, yeah, just wait for a moment. So I'll go to that particular equation. Okay, A equal to matrix of, you can see what will happen here right now, because here it will be solved in a different way. Okay, what was the question? 1 2 4 3 1 comma 2 comma 1 comma 2 comma 4 comma 3, and by row anything equal to 2. So 1 2 4 3 by row equal to 2, that is fine. A equal to this matrix, and I'll just copy from here. So EA I am putting eigen of A, so just, and EA I will find eigen values. If I see, it is coming as minus 5 1 itself, 5 minus 1 itself. Okay, it's coming as 5 minus 1 itself. That is fine. Okay, now if you look at the vectors, see the value, anything which you can find out here. This is different from what we have found out. Okay, so you can find any eigenvector which is satisfying any particular equation. Okay, so 1 into 2 like that, some other case it has found out. Put
Sorry to disturb. Just instead of EV, can
sorry,
we make it as EA?
Yeah. Sorry.
No.
Yeah. Here, yeah. I forgot. Sorry. So now you can see here. Here you can see any relation here. Kind of 1, 2 is there. Right? I mean x1, x2, 1, 2 is coming. Here it is 0.447 and you can find it like this now, right? Yeah. And here also in the next vector minus 1, 1 we had put. Here you can find it out like minus 1, 1, minus 707 and the other one is 0.707. Okay. So anyway that relation is coming. In the first case it is like x2 equal to 2x1 is coming, and in here the second one x1 equal to minus x2 is coming. Okay, so relation is coming, but anyway you can have different number of solutions. Okay, Jason, I think it's clear now. Okay, yeah. Okay, so have I missed anything else? Decast. Okay, I think I have one problem which had come in the last set. I have changed there, but just I'll see. Okay. Sorry. Okay, I will just open that file. Okay, what have I done here? Okay, yeah. Okay, so decast was in your week 1, right? So this is like okay. So there are, in that particular thing there is melt as well as cast, cast, okay. So just wait for a moment. So in that particular thing there are 3 different things, okay. So I think I had given like this one. Yes, I think I have given like that. Wait for a moment. So it's both in the reshape 2 library. So there is melt as well as there is the cast, okay, and then together you will be doing melt as well as decast is there, and together you will be having the recast also, okay. So for that what you have to see is that you just look at the syntax first, okay. So syntax, if you want to see, I'll go back to the RStudio and okay, just let me load this one. Okay, it is there. Then melt. Okay, anyway, melt. Okay, wait, this is melt, okay, data, this one, further arguments like that, okay. So one example, I'll do this one. This was the example that was shared last time, okay. So this is the student's course name, mathematics, English, science. It's given mathematics these values, English and science these values. Okay. So yeah. So melt, if you are doing the melt equation, I mean the melt thing, your objective is like, okay, to change this particular thing. Okay, so this was a question, and in that question they wanted to give a particular thing where the thing was name and the other things like the variables were mathematics, English and science, and they wanted the value. So there the intention was like, you have to give the name, you have to get the some value, and I mean some variable here and its value. So the intention there was to get the names here like that, and value for like mathematics, science like that, and value for each one, like for example 30, 40 like that. So in this case, if you want to form a table, okay, so right now if you look at this one, your table is like this. Okay, if you want to form a table with name and a particular column where marks, like if you have, say you can tell it as marks, where all the three subjects are present and their values are given side by side, you can use melt. That is what melt does. Okay, then decast is another thing. Okay, so if you do melt, melt is coming like this, name, variable and value. Okay, that's what I've shown in here, sorry, in here, name, that variable and its value is coming. Okay, now decast will be like another kind of operation where, okay, so for decast we want this particular operation. Okay, so last time I hadn't done this, that's why that error was coming. So the student melt, I have just given a new variable and it's given like melt. I am first doing the melt operation. Okay, because here what I am giving is like in the decast option. Okay, I'll just call that one also decast. We will look at that. F1 cast functions, data frame into an array or data frame. Okay, depending on whether, so it's like data, you have a formula and then some other arguments are there. So here there is a formula. Okay, so for applying that particular formula, I mean this particular kind of thing should be there. Okay, so for that, I mean earlier that particular this particular statement was not present in the last one. Okay, so last lecture when I was doing, so that's why decast could not be applied. So here student melt equal to, I am just giving it like melt in student's course, right? That is the variable. Then ID of variables, I am giving like name, and measurement of variable measure.vars, I am giving like this. So this is the same thing that we have done earlier. So student melt is coming like this. Okay, now in decast we will be using a formula. So in formula column I am just giving like variable plus name. Okay, so here the variable is this one plus the name I am giving like this. Okay, let it be all. If you have a particular column which should be given, you can give that particular column, but here there is no other meaning, I mean any meaning won't be coming. Okay, there is no other particular column there present. If you look at the example which was given in your lecture, it can be molded like that. Okay, so here since there was nothing like that to be given, I am just giving here this variable plus name I am giving, and since I didn't put anything else, it's giving the value as this one. Okay, so value dot variable, so whatever value should be coming I am giving like this. So first the variable is taken and then the name is taken here and the value is given here. So this is like decast. Okay, now so that is decast. And if so, right now what I did, I have done the melt as well as decast. Okay, so together, if you don't want to do the separate two options, then you can go for the recast option, which is like this one. Okay, I will do that once again. So this is recast. So in recast melt and cast will be done in a single step. Okay, so this will be conveniently wrapping, melting and casting. The casting means decasting a data frame into a single step. So here its arguments will be data, that means student's course, then whatever formula you have to give, then ID variables, measure variables, everything you have to give. Okay, so recast you have to give, I mean whatever is the variable there, then whatever is the formula. So formula anyway you can give like this, but in this particular thing it won't be coming clearly. So anyway I am giving that one, and then ID variables what should be given, and measure dot variables what should be given. Okay, so just I am including everything. So just see here, ID variable, measure variable, everything should be given. Data formula, ID variable, measure variable. I think we have given everything here. So just see if it's running. Okay, it's not there. Use, oh sorry, there it is. ID dot, yeah, and this one. So it's coming as the final value which was given for decast. I'll just put this on the top. See here, mathematics, this was the final thing which we had done for melt as well as decast. So if we, when we did the recast function, that same answer has come. Okay, so Jason, are you, not Jason, Kohli, are you clear? Rajwan Kohli?
Yeah, I've got a good idea now. Only question is, how many different variations are there for formula? Because formula can be changed by column names order.
Yeah, you can do that. The thing here is like, for example, in your particular data frame, if you have something like you want to add the values of two different subjects, or if, for example, if you have marks of assignment 1 well as assignment 2, something is like that in your particular data, then you can do give that in formula. Okay, but only thing is that particular column should be there. Okay.
Oh, okay, ma'am. Okay.
Yeah. Last time it was not there. That was so I have changed that in the programs. Okay, you can find that in the drive. Okay. So I think.
Thank you.
Yeah. Then I'll just go through some of the things. Just the chat is fine, I think. Week 2 PPT. Okay, that will be shared. Okay. The concept of rank of the matrix. Okay, yeah. Pragma. That is, I mean, I have also used that library. Okay, it was already loaded, so that, I mean, wait a moment. Yeah, this is the library. Okay, it has to be used. Okay, for finding out the rank or inverse or anything, that library is required. Okay, link will be shared. Okay, link will be shared later. So the Pragma library, just, yeah, I'll just show you this thing. Practical numerical math routines. Okay, so here many things are there, right? So this library is required when you have to find do the different matrix operations, like wait a moment. Okay, so okay, just what was that? Yeah, the thing is, yeah, these are the different things that you can do. Okay, many different things are there. So here we have done it for the different matrix operations. Okay, so if you want to find the inverse of a matrix, if you want to use the solve, if you want to find the rank, everything is available in this particular matrix. That's why you have used it. Okay. Who had asked the question? I've been getting, what error was that? Can you tell me, Navya? Can you tell me the error that you are getting? Library not found. Okay, yeah. So what you have to do is, either you have to type install.packages pragma. Okay, that you have to type. Since I've already downloaded it, I mean already installed it, it's showing here. Okay, just check in here packages, just check pragma. Okay, if it's showing, it's installed in the library. If it's not, you have to go to this install, search for this thing pragma. This is one way. Okay, and click install. Okay, another way is like install.packages. If you know the package clearly, then you just have to type pragma, and after that what you have to do is library of pragma you have to enter, that you have to run. Then it will be added to your present console. Then you can do the different operations. Okay, now I think if you test it, it's fine. In matrix are free variable and independent variable same. Okay, I haven't seen that usage there. Anyway, wait for a moment. That is actually not related to this one. Okay, that is related to what is it like? It's like in row, in the echelon form or something you will be seeing. Just I think you have to look more at matrices, matrix operations. Okay, independent variable is different. Okay, in that you have to reduce the, any other question? Just I think everything is, I'll be sharing this one. Meaning of biro equal to true. Wait, I'll come to that. Just I'm checking if anything else is to be explained. Okay, these are things I think if you read the equations you'll find. Okay. Biro equal to true or false pair. Okay, this one you can tell. Okay, wait. Okay, just I will give this particular matrix. Okay, now A is written like this one, C 10 8 5 12. Okay, I have given biro equal to true. Okay, so it will be coming like row wise, it will be added 10 8 5 and 12. Okay, now if I am not giving that, biro is equal to, just I can put F also, false. Then if I do that, it will be coming like 10 5 8 12. Earlier it was 10 8 like that. Okay, sorry, I'll show you the difference also. F and pyro equal to 2. Okay, let me run these three so we can see the variation. Okay, see here, A is equal to like this, by row equal to 2 I have given, then it will be filled by row 10 8 5 12. So first the row will be filled. Okay, row wise it will be filled 10 8 5 12. And if you are not giving, if you are not giving anything else, by default it will be filled column wise. So it will be coming like 10 8 column and then 5 12. Okay, so Monica, is it fine? Yeah. And print matrix T and 3 C1 generate another after performing T of n. Okay, let me try. Can't directly paste from the, okay, wait. Okay, Studio. Okay, we will see. Print M matrix. Okay, you are printing it directly. Okay, first one matrix 1 2 3 4 5 6 7 8 10, by row equal to 2 you have given 3 columns. Okay, that's fine. Okay, then this one n, what have you given here? Matrix C. Did you give C? Or you have given, okay, you have not given C? Jayashree? Not Jayashree, sorry. Chandan, have you given C? Okay, I think you have given, sorry. Okay, then if I run here, it's coming like 10 11 12. You have given, yeah, 1 3. Okay, then you did a C bind. Okay, we'll see. CB, C bind, NM. Okay, column bind, can you do there? Just I will put, just I will try there. Okay, can you do a C bind there? Because just I'll show the two matrices M and N. Okay, so the M matrix is like that, 3 by 3 matrix, 1 2 3 4 5 6 7 8 9. How can you bind this one? Concatenate that one N, which is of this form, 1 by 3 to a 3 by 3 matrix. How will it be possible? That operation is actually not possible. Okay, yeah, that's why it was showing an error. So only thing that you can do is, if you want to concatenate row wise, then you have to give an R bind. Okay, column wise you can't do in that particular shape. So if you give R bind, there will be no errors. Okay, that's why I perform. Oh, you performed that. I didn't see that. Okay, sorry. So I think you did a transpose of N. Okay, then let me see that. Okay, it's coming like that. Then you should put what you know. Like that you should put. Okay, now we will see. Okay, wait. Oh, sorry, now I have done this mistake. Yeah. Okay, now it's fine. Chandan? Yeah, it was just like you have just first have to visualize how it's coming. Okay. Yeah. So I think it's already 8:15. Anyway, I have many other examples for you. I'll be sharing this. Okay. Sharing these 3 files as well as the files which I have examples of what was showed in your lectures also. So all this I'll be sharing with you in the Google Drive. Okay, so you can practice that. Fine. Okay, so just I'll go through the chat if there is any other install packages. Jasri, what is this? Okay. Okay, for you, I think we will just put it here. Okay. Wait a moment. I think you can check the error code in this one. Okay. There is some problem with your packages. Okay, I think for you I will paste this link. This you can check. Okay. But Google Drive link I had shared earlier. Okay, anyway I'll share it again once more. I haven't included week 2 things. Okay. Yes. Okay, so I think it's fine. Okay, everyone. Any other questions? Okay, so I think we'll wind up for today. So everyone have a nice rest of the day. Thank you. I'll be sharing the material, right? Okay. Okay.